And we begin Chapter 8, Hypothesis Testing, with the basics of hypothesis testing. So in this section, we're going to cover essentially the key components of the hypothesis test, and then in the next sections, we'll actually conduct them. So there's a lot of vocabulary here, a lot of procedure. Make sure you pause, take lots and lots of notes, and then we'll apply it, and that might actually help formalize some of these concepts from 8.1 when we start to apply it in 8.2 and 8.3. So why would we hypothesis test? Well, when researchers are interested in answering many types of questions, and these can be addressed through statistical hypothesis testing. So a hypothesis is a claim or statement about a property of a population, and it may or may not be true. And then the hypothesis test, or a test of significance, is a procedure for testing a claim about the property. So these are the 7 steps we'll be using as we progress throughout this chapter. The textbook has a nice graphic here that you can use as well, but we're going to identify the original claim, express it symbolically, then identify the null and alternative hypothesis. Then we're going to use our calculator. We'll identify the test statistic. We're not going to do that so much in this section, but we will in the following ones. We'll choose a method. Almost always you're going to want to go with the p-value, but we'll do both. Because you can find the p-value using your calculator the same as the test statistic, that's ideal. But then we can also, we'll do the critical value as well, but in the future you'll most likely just use the p-value. You'll make a decision based on some criteria in this section and restate the decision in non-technical terms. So step 1, identify the claim and express it symbolically. So for symbolically, here are some common phrases that go with symbols if you're someone who's had difficulty in the past with inequality symbols. So let's look at an example here, and we're going to use this example throughout. So 1,009 consumers were asked if they are comfortable with having drones deliver their purchases, and 54%, or 545, of them responded with no. We want to consider the claim that the majority is uncomfortable with drone delivery. So it wants us to state the claim, then denote the claim in symbolic form. So the claim here is that the majority is uncomfortable with drone delivery. So how we would express that symbolically, they want us to use P. So the majority is more than 50%, right? So we would say P is greater than 0.5. This is the claim. So identifying the null and alternative hypothesis come after you determine what the claim is. The null hypothesis is a statement that is equal to some value. Some people call it the no difference hypothesis. So null hypothesis, think equality, and we denote it with this symbol here. And then the alternative hypothesis is actually denoted a couple different ways. We're going to be using this notation in this textbook. And the alternative hypothesis is basically when it's not equal to. It's not equal to, less than, or greater than. So if there's no equality, it becomes the alternative hypothesis. So just like I said, if the claim has equality, it becomes the null hypothesis. If the claim does not have equality, it becomes the alternative hypothesis. And then you also want to note which is the original claim when you're writing the null and alternative, because that's going to help us with our final step. So we know that the claim is P is greater than 0.5, so state the null and alternative hypothesis. So essentially the question is, does the claim have equality? And it doesn't, it's greater than, so that would become our alternative hypothesis. And so our null hypothesis would be the one with equality, that value with equality. And then we would note, okay, this is the original claim. We'll do another one. A healthcare provider saw that 48% of their members received the flu shot in a recent year. The healthcare provider tried a new advertising strategy in the following year, and they took a sample of members to test if the proportion who received their flu shot had changed. So the claim here, right, we have, even though it's asking for the null and alternative, we need to investigate the claim. The claim is that the proportion has changed. It's not equal to 0.48 anymore. So when we go to determine our null and alternative, we would say, okay, that doesn't have equality, so that would become our alternative, and therefore this would be our null. We'll do one more example. A quality control engineer is testing the battery life of a new smartphone. The company is advertising that the battery lasts 24 hours on a full charge, but the engineer suspects that the battery life is actually less than that. They take a random sample of 50 of those phones to see if their average battery life is significantly less than 24 hours. So the claim here, what we're trying to figure out is the average less than 24 hours? So when we go to write our null and our alternative, and actually I should go back here, right? This one is our claim. So this does not have equality, so we're going to make that our alternative, and therefore our null is going to be that it is equal to 24. So go ahead and try these, pause, and then press play. This is a super critical component of 8.1, so please make sure you pause and give these a shot. And there's the solutions. So I have this taken off. This is significance level is actually on the graphic from the textbook, but this will usually be provided to you. We really want to make the significance level, smaller. So we normally use 0.05 and 0.01 are really common. This is the same significance level alpha that was introduced in section 7.1 when we were talking about the critical value. And these are some common choices. Again, you're not really going to have to choose. They'll be provided for you. So then identifying the test statistics. So this goes back to our previous understanding of proportion and mean. So this calculation here of determining the test statistic, we're going to do that in the calculator, so you don't need to worry about that. But what we do need to understand is if we're talking about a proportion, we're looking at z. If we're talking about a mean and sigma is not known, we're talking about t. If we're talking about the mean and sigma is known, then we're talking about the z. And so that's important to know which kind of test statistic, z or t, and then are the requirements met? So we're going back to our original drone here. Okay, which test statistic do we choose? So they're asking about the majority of the population. They're asking about a proportion. So we're going to use the normal distribution. We're going to use a z test statistic. So we're going to use a z test statistic. And they want to know if the requirements are met. So is n times p greater than or equal to 5 or n times q greater than or equal to 5? So we know that our p, right, is 0.5. So is 1009 times 0.5 greater? Yep. And the q would also be the same value. So yes, our requirements are met. So now in the next section, I'll show you how to use your calculator, but you're going to end up getting something like this when you do a proportion z-test. And so this would be a result you would get for this example. So now we need to determine what is the actual test statistic here. So when we're given this, the actual test statistic, remember we said it was a z, our z test statistic is z equals about 2.55. Now what this means is we're going to test this value in the critical region if that is the critical value method that we're going to use. And again, we're just kind of starting it, and if you're like, I don't really understand, we apply it, and actually applying it in 8.2 and 8.3 is going to make this make a lot more sense. So after you've determined your test statistic, we would choose a method, and almost always you're going to want to do the p-value. It's easier, it's quicker, and it's easier, but I am going to show you how to do the critical value or the traditional method. And then after you choose your method, you find the p-value, which would be in your calculator, really easy, or the critical value, which has just a couple more steps. And this process we're going to cover in our next sections. But let's say we do the p-value. We would use the calculator to determine the p-value. And so we just need to be careful that we're using the proper notation here when we are talking about the p-value. So we do capital P-value because lowercase p is our population proportion and p-hat is our sample proportion. So let's look again back at this. We already saw that our test statistic was the z here. What is the p-value? And this right here would be our p-value. So our p-value would equal 0.005. You could even go to 4 digits, a minimum of 3 digits there. And that's how you calculate your p-value, which is why we would almost always want to use it because it's pretty easy. The critical value method is a little bit more work, but first you would need to determine if the test is two-tailed, left-tailed, or right-tailed, and then that would determine your critical region, which tells you when to reject the null hypothesis. But so let's take a peek here. So we determine if it's left-tailed, right-tailed, or two-tailed. Then we draw the curve and shade the critical region. And then we would use spreadsheet technology to determine the critical value. So we still have to determine the critical value. It's the z-value of the critical value is not the same as the test statistic. And again, this will become clearer. But there are some good ways to think about left-tailed, right-tailed, and two-tailed. So two-tailed is when we've got a not equal to. Left-tailed, you can look at the way that the arrow is pointing, the symbol is pointing. That's a left-tailed. A right-tailed is going to be a greater than. Here's another graphic if that's helpful for you. So if we were using the critical value method on the same example we've seen multiple times, would this be a two-tailed, left-tailed, or right-tailed? So we would look at the symbol of our alternative hypothesis, and it is a greater than symbol, and it's pointing in that way, so this would be a right-tailed test. The critical value is the value that separates the critical region from the values of from the other values, and then we would determine if the test statistic is within that critical region. So we have the same thing here. They give us the significance level this time. They want us to draw the critical region and determine if the test statistic lies in the critical region. So first we would determine if it's a left-tailed, right-tailed, two-tailed. We know that this is a right-tailed, so I'm just going to draw it right here. And we're trying to find our critical value z. So we know that this critical region is our alpha. So this must be what we're going to type in here to get our critical value. So this is using all of our old stuff here. So we would do norm dot the probability. We're in the standard, so it's 0 and 1. So we get 1.645. So now, 1.645. Something kind of funky happened there. So our test statistic is 2.55. Where does that fall? Remember, this is 0. Our test statistic is going to fall way over here. So that's where our test statistic falls. And we'll deal with that later, what that means. But so our test statistic is in the critical region there. And the confidence interval method we really don't use, but if you want to take a peek at how it relates to hypothesis testing. And we're going to pause there for part 1 and continue on in part 2.